class, right? So we record, right, the video, okay, for today's lesson. Okay, so we're gonna learn about inertia. Okay, so what is actually inertia? Okay, so first one is, okay, let's say when we stood in a bus, okay, and we starts, okay, and suddenly from rest, okay, so actually the bus is first at rest, then when we start moving, okay, so we are likely to fall backward. Okay, and if the moving bus stops suddenly, okay, we are likely to fall forward. Okay, so what caused these two situations to occur? Okay, so the two situations above shows that our body has an inbuilt resistance, right, to any change in state of rest or motion. Okay, so this reluctance to change is called inertia. Okay, so let's say when at first, right, the bus is not moving. Okay, so means our body is also at the rest state, right? And then when it start moving, okay, then our body will fall backward, right? We fall backward. Means our body will resist the change of motion. Okay, that means it resists the change of motion of the bus, okay, to move forward. Okay, so that's why our body move uh, backward. Okay, okay. Let's say if the bus is moving, okay, and then suddenly it stops, okay, then our body will move forward. Okay, so means this at this time our body resists, right, the change, okay, to stop. Okay, so that is call it as the inertia. Okay, the tendency of our body to resist any changes in motion. Okay, so what does it mean by inertia? Okay, so the tendency of the object to remain at rest, or if moving, it continues to moving, okay, but in a straight line. Okay, so that's the meaning of inertia. Okay, inertia is also known as the Newton first law. Okay, so Newton first law is inertia, and then you will learn later Newton's second law, that is F is equals to ma. Okay, but this one, the law of inertia, we call it as a Newton's first law. Okay, next, every object continue in its state of rest or of uniform motion in a straight line unless it's acted on by an external force. Okay, what does it mean here? So let's say if the object is moving, okay, is moving in a straight line, it will continue to moving in a straight line, okay, unless, okay, you give an external force to the object. Okay, so that we call it as the first law of Newton. Okay, first law of Newton. So let's say if the body is at rest, rest state, okay, at the rest state, so it will continue to be at the rest state, okay, unless you give the external force for the object to move. Okay, so before we answer this question, okay, I would like you to see this video first.
Imagine you're sitting on a recliner chair watching your favorite movie on a lazy Sunday. And your mom calls out your name and asks you to run some errands. You can imagine how difficult it would be for you to get up and do the work. Imagine you're practicing for your 100 meters race on this track. And somebody asks you to stop immediately within a second. Will you be able to do it? What if you're suddenly asked to turn towards the right? Will you be able to turn immediately? The answer to both the questions would be a no. You can stop, yes, but gradually. You can also turn, but not sharply. And guess what? It's the same story with every object. Every object will continue to do what it's doing. If it's at rest, it will remain at rest. And if it's in motion, it will stay in motion. But what can change this? Yes, only an unbalanced force can change this. If it's at rest and an unbalanced force acts on it, it will move. If it's in constant motion and an unbalanced force acts on it, it may accelerate or change direction. And this is nothing but the Newton's first law of motion. Here's the correct definition. An object at rest stays at rest, and an object in motion stays in motion with the same speed and the same direction unless acted upon by an unbalanced force. In simple words, it means that the objects continue to do what they're doing unless some external unbalanced force acts on them. We can also understand this using a simple diagram. If the forces are balanced, there can be two cases. An object may be at rest, or an object will be in motion at a non-zero constant velocity in a particular direction. These can be the only two cases when the forces are balanced. In the first case, the object will continue to remain at rest, and in the second, the object will continue to stay in motion at the same velocity and in the same direction. Don't forget, these two cases will remain true only if the forces are balanced. In the next video, we will look at a few.
Okay. So for this one, I think you already understand, right? What is actually inertia? So inertia is actually the tendency of an object, okay, to resist any changes or motion, okay, to their movement. Okay. So like I told you before, if the object is stay at rest, so it will remain at rest unless you give a force to it. So and if you give a force to it, it will move, okay, with the acceleration. Okay, but let's say the object is already moved with the uniform velocity, then give a force, okay, to the object, it will be the acceleration will be increased. So and then also it may change the direction of the object. So both of it, okay, it shows that the object has a capability, right, to resist any changes, okay, in motion or in the direction, whether the direction or the magnitude of force. Okay, so this is the meaning, this is actually the inertia. Okay, let's say for another example, okay, in our real life. Okay, so let's say if you take part for 100 meter, okay, and then of course you already know that we will run so fast, right? And then suddenly when we want to stop, okay, then our body will fall down like that. Okay, it will fall down. Okay, so that is also the example of inertia. Our body keep wants to move, okay, but we want to stop. Okay, so that's why we fall down. Okay, that is also the example of the inertia. Okay, all right, so I continue to the next part. Okay, so this is the first activity that you can do, okay, at your home, okay, to see the effect of the inertia. What's actually the example of the inertia? Okay, so let's say for this one, you place a cardboard, okay, on the top of a glass, and then you put a coin, okay, and then you flip the card horizontally with your finger. Then what will happen to the coin? So the coin will move to the glass, okay, it will fall into the glass. Okay, so when the cardboard is pulled away quickly, the coin drops straight into the glass. Okay, and then you have to explain the observation why it goes straight to the glass, into the glass. So the inertia of the coin maintain its state of rest. So that's it. He don't want to follow the flip. Okay, the cardboard. Okay, he don't want to follow the cardboard, so it will fall down to the glass. Okay, so the inertia of the coin maintain its state at rest. Okay, so the coin falls into the glass due to gravity. Okay. Alright, the next one. Okay, so this one make a stack of the 20 cents coin on a smooth surface. Okay, flick another 20 cent coin toward the stack, and then to knock the bottom coin out without disturbing the rest. Okay, so this one how to explain the concept of inertia applies, right? So the inertia of the upper coin want to remain at rest. Okay, so it will move downward without following the knock coin at the bottom. Okay, so this is the example of inertia. Okay, and then another example, if you put a glass of water, okay, on the top of the A4 paper. Okay, so what will happen to the glass of water if you suddenly pull the paper horizontally? Okay, so what will happen? So the inertia of the glass with water wants to remain at rest. Okay, so it will still stationary, okay, without following the paper. This one is actually same as the coin, okay, on top of the cardboard just now. Okay, you can see the coin drop, okay, drop straightly into the glass. So this one is also same. Okay, it will stay at the place, okay, without following the A4 paper, right? Okay, and then the next one. Okay, so let's say we place a block of wood, okay, on top of the trolley, okay, and then we let the trolley move down the runway. Okay, and then stop the motion of the trolley with the book. So we put the book at the end of the uh, at here, right? So and then we have to observe what happened to the wooden block. Okay, so the wooden block fall forward. Okay, so explain your observation. So the wooden block move together with the trolley. Okay, and then when the trolley want to stop, the inertia of the wooden block wants to remain moving forward. So it fall forward when the trolley stop. Okay, so the book, okay, we stop the wooden block. Okay, and then the wooden block stop. Okay, but the book, okay, the book we stop the trolley. Okay, okay, but the wooden block still want to move. Okay, so it will move forward. Okay, it will fall forward. Okay, because of its inertia. Okay, it's the tendency for the wooden block to still move. Okay, but the trolley is already stopped, right, by the book, but the wooden block still want to move. Okay, so that's why it's fall forward. Okay, and then the next one. Okay, so use a hammer to pull out a wooden block from its central location. Okay, so what happened to the other wooden block on top of the block which is pulled out? Okay, so what will happen? The other wooden block on top fall down. Okay, so this one means the other wooden block at the top doesn't want to move. Okay, so it will fall down, and the inertia of the blocks want to remain at rest. Okay, and then this one we investigate, right? What is the relationship between mass and inertia? Okay, so I give you an example. Okay, so let's say at the traffic light like that. No. Okay, let's say there's a lorry. Okay, there's a lorry and then there's a bicycle. Okay, so let's say they want to take a turn. Let's say they want to turn right. Okay, so which whether sorry, if is it the car or the lorry, okay, easy to make a turn. Okay, so of course uh, sorry, just now I use a bicycle and the lorry, right? Okay, so bicycle and lorry, which one is easier to turn right? Of course the bicycle. Why? Because you will answer that the bicycle is lighter than the trolley, right? So actually that one is also considered as a inertia. Okay, so the object wants to continue to remain forward. Okay, but we want it to turn right. Okay, so which one more easier to turn right? The bicycle, because the bicycle, the inertia is lower compared to the lorry there. Okay, so that's why it easy for the bicycle to turn right. Okay, so this one is we can connect that the mass influence inertia. Okay, so the lower the mass, the lower the inertia. So that is the relationship. Okay, so for this one, okay, they use a trolley. Okay, so first one, the trolley A and the trolley B. Okay, so which one is much easier to pull? Okay, sorry, to push. So the one that is a trolley A. So trolley A is lighter and easier to move. Okay, so which trolley has a greater inertia? So of course the trolley B has larger inertia, okay, because the mass is greater and it difficult to move. Alright, so it's same like if you play a swing. Okay, let's say you play a swing. So we compare adult and a child. Okay, so which one is easier for you to push the swing? Of course the child, because the child that has a low mass, okay, compared to the adult. Okay, so it's easy for you to push the swing, okay, compared to the adult. So this one is actually also inertia. Okay, so you can change let's say the swing first is at rest, right? So if you want to pull, you give a force to it. Okay, So which one is easy for you to push? So of course the child, because the inertia is lower because of the mass. Okay, the mass of the child is lower than the adult. Okay, so that one is also the example of the inertia. Okay, and this one, okay, they put the sand, okay, in each can. Okay, so which can is easier to move? Okay, so of course the one that empty can, right? So the empty can is easier to move. Okay, and then the next part, okay, let the two can swim. Okay, so which can is easier to stop? Of course the empty can. Okay, because the mass is smaller, so means the inertia is smaller, so means it's easy for you to change the direction and also to give a force, okay, to the object. Okay, which can has a higher inertia? The can with sand. So now you have to state the relationship between inertia and mass. So the larger the mass, the larger the inertia, and the more difficult to move or to stop. So means for the can that have sand, okay, inside of it, it's easy for it to it's difficult for it to move, and also it's difficult for it to stop, okay, because of the large inertia. Okay, so what is a physical quantity which describe inertia? So this one is a mass. Okay, for this topic there is no formula, okay, there is no calculation. So what you have to remember for this topic is actually the meaning of the inertia, okay, the tendency of an object to remain, okay, on its original state of motion, okay, whether it's at rest or it's moving, even moving into the uniform velocity and same direction, okay, unless there are external force acted on it. Okay, it's a quite long meaning, but you have to remember. Okay, and sometimes the question, they don't ask you what is the meaning of inertia. They ask you to state the first law of Newton. So you have to remember, first law of Newton is actually inertia. Okay, so first law of Newton is actually inertia. So you just give the meaning of the inertia, okay, for the first law of Newton's law. Okay, and then for number 3, so this one you always do in your home, right? So they say the sauce, right, is will not come out, right? Will not come out from the bottle. So you have what you have to do, okay? We will keep shake it, right, until it come out. Okay. So what is the tomato sauce can be easily poured out if the bottle is moved down fast with a sudden stop. Okay. So mean the sauce move together with the bottle. So when you start shake it, okay, and then you stop suddenly, the initial of the sauce want to keep continue move. Okay, but the bottle is already stopped, right? So the the sauce will pour out from the bottle because it still want to move. Okay, but the bottle is already stopped, so it will keep the sauce will pour out from the bottle. Okay, next is the if you're chased by a cow, okay, how you will run? So run in a zigzag way because cow has a large inertia. Okay, large mass means large inertia, so it's hard for the cow to change direction, right? So if you move in a zigzag, okay, in a zigzag direction, so when the cow want to follow you in the same way like zigzag also, it will take some time for it to move. Okay, okay, so run away from a cow in the zigzag motion. The cow has a large inertia, making it difficult to change direction. Okay, and then the last example is the wet umbrella. So wet umbrella can be dry by moving it very fast and then stop suddenly. Okay, so you just keep moving the wet umbrella. Okay, and then after that you stop. But remember the inertia said the water will still want to continue to move, right? Even you already stopped the umbrella, but the droplet of the water still want to move, so it will move. Okay, so then when the umbrella is stopped suddenly, the inertia of the droplet continues its state of motion and left the umbrella. Okay, so this is also the effect of the inertia. Okay, and then for this one, okay, So you have to explain why the massive oil tanker takes a long time and a few kilometers to come to a stop. Okay, why not just like suddenly when you reach at the place you want to stop, and then why not just stop like that? Cannot, because the the oil tanker, they have a large inertia. So large inertia means they have to take some time, okay, to stop. Okay. So the answer is the tanker has a great mass, so the big inertia cause it difficult to stop the tanker. Okay. Right. So that is for the inertia. Inertia is a very small chapter. It's not so many things. Okay. Unlike the momentum that we will learn the next. Okay. So what I want you to do, okay, I think I give you the tutorial, right? So tutorial 2.4. Okay, so before that we see this video first.
Imagine you're sitting on a recliner chair
Not this
watching
one.
your favorite movie on a lazy Sunday. And your mom calls out your name and asks you to run some errands.
Sorry, not this one. Okay, but this one, yeah. Wait, I find yeah.
Studying sucks. Homework takes up too much time. And school is boring AF.
Inertia, we need to look at Newton's first law of motion again. Here it is. In simple words, this means that objects tend to keep on doing what they are doing. It is the natural tendency of every object to resist change in their state of motion. If they are at rest, they would prefer staying at rest. And if they are moving at a constant velocity, they would want to continue doing so. This tendency of objects is called nothing but inertia. It's the natural tendency of an object to resist change in its state of motion. Yes, you already knew what inertia is. And yes, Newton's first law of motion is also called the law of inertia. Do you think all objects have the same inertia? All objects resist changes to their state of motion, right? So all should have the same inertia, correct? Well, not really. Because inertia tells us how strong an object's tendency is to resist change in its state of motion. Think of it like this. There's a tiny brick kept on a table next to a relatively larger and a heavier brick. Which one do you think would be easier to push? Without doubt, the tiny brick, correct? Yes, but why is that? It's because the heavier brick's tendency to resist change in motion is more. The heavier the object, the more is its tendency to resist the change in motion. The more mass an object has, greater will be its inertia. So if we apply equal force to both these bricks, the tiny brick will move further as compared to the larger brick. The heavier brick has more inertia. How can we relate inertia and mass? Inertia is the tendency of an object to resist changes to its state of motion, and the mass of an object is the measure of its inertia. In the next part of this video, we will understand this relation with a few interesting examples.
So that's the video. Right, so I want you to try to do the tutorial 2.4. Okay, I think like only one page, right? And for those who still didn't go and take the module at school, please go and take the module. Okay, so I want you to do the objective question number 1 until 11. Okay, number 1 until 11. Okay, before that, I just want to tell you, okay, make sure before the school open, okay, you finish up all the module. Okay, means the module is complete, and also tutorial also must be complete, because I will check. Okay, I will check when the school open. Okay, so make sure you did, okay, tutorial, because I think already give you the answer, and also we already discussed all, okay, the module, the notes, so there is no reason for you to not complete the module and also the tutorial. Okay, so I think I will stop until here. Okay, so I will do the next video for the momentum. Okay, let's say if you have a question you want to ask me, okay, regarding anything, okay, whether the tutorial or some of the part from the video that you cannot understand, okay, so please you can text me, okay, I will reply. Alright, so take care, okay, stay safe, okay, thank you class, right, bye.